Hello, my name is Zach Denham, and my hack is called RipDB. And RipDB is a developer tool, and it's a dead simple, fast, decentralized JSON store built for Web3 builders who want to move quickly. And under the hood, it's using Redis backed by IPFS, and that's RIP. And I like to think that it's going to be a database killer, but I say rest assured, no databases are harmed during the process of this hack. So what is the problem? Relational databases are pain, and I come from a Web2 background where we had to use them all the time. You have to deal with migrations. They're centralized treasure trove for attackers. They usually don't give users provenance over their data. You have to do things like encryption and key management, and there's boilerplate context switching to write SQL queries. Overall, it slows you down. It's a very powerful tool, but if you can't avoid it, I would. And that's my backstory. In May 2022, I decided I was going to break up with traditional databases as I made the jump into Web3. And I solemnly swore not to use any databases for the NFT platform I was working on because there are so many great indexing services that index all this blockchain data. So you can just rely on them, like the Etherscans of the world. So why have your own database? Just let them do it. And the backstory is also that I found that I did need to store some data that was not on indexers. Particularly, my use case came up when I need to calculate some Merkle proofs, and you have to store all the leaf nodes off chain for Merkle proof. So I had a relapse, and I'm like, oh man, I got to store this data now for this application I'm working on. What do I use? And I thought really from the ground up, like what would be the perfect solution for me? And it would be something that was really, really good at preserving developer velocity, because that's something I care about a lot. I want to move quickly, and I want it to be fast, snap experience for the end user, but maintain decentralized redundancy and also support encryption. So I decided to combine two awesome technologies. One is a tried and true Web2 cache called Redis that's super, super fast in memory. And then I was getting the redundancy from IPFS. So your data is stored in Redis, but backed up on IPFS. And that's how RIP works. And I built a demo. And the way that you use RIP is actually on a front end client. And so I built out a demo, and you can actually try it out here. You have a key, choose your key. Hello. You can generate some dummy data and store that data and see how fast it is in RIP. 2 milliseconds is insanely wicked fast versus about 2.5 seconds to back it up on IPFS. Once you've stored your data, you can fetch it. 1 millisecond from RIP, which is again insanely fast, thanks to Redis. 2 seconds to fetch it from IPFS, and then you can actually encrypt your data by connecting to Lit protocol with your MetaMask. Sign the transaction. Now we're connected, and if you encrypt and set the data, you can see your data is now stored encrypted. You have ownership over it. The encryption key is also stored in RIP. You still get the fastness of RIP, but the decentralization or the encryption is on the client. So you can fetch that remote data and decrypt it, and you have your data. So that's a little demo of how RIP works. This is a live website pointing to a RIP client on my local host. And then the end experience for the developer is super simple. You literally just import the client on your front end, and then you can set data and you can fetch data. And that's about it. It's perfect for my use case, and I hope that other developers will enjoy RIP as well.